say that increased cola consumption is associated with, the words they use, lower bone mineral density. Yeah, it's associated, that's the word they use. And the reason for that is because of the potential lurking variables, and because it was an observation study. And then they never said that increased cola consumption causes lower bone mineral density. So in this chapter, they're all going to be observational studies. We're never going to say that one is going to cause the other. We're just looking to see how they're related and how closely related they are. Goodness. Okay, so we're going to start a little bit with 4.2. Real quick, just briefly introduce it and then we'll finish it up. On Monday, they've got this sample data that they just completely made up. It doesn't actually come from anything in real life. They've just got their X's and their Y's. And then they just got to go through and kind of set up the idea behind a least squares regression line, which we're going to get more into next time. But they want us to find a linear relation between the two things, so they use a little bit of algebra magic, which you don't have to do. You won't have to memorize these formulas or anything like that. That's why I left it all on there. We're not going to do it by hand. So they picked two points. They picked this point and this point. Yep. And they're going to draw a line between those two just to kind of approximate what they think the line might be, since it is a linear relationship, which we didn't show it was, but it should be. So they go through, they find the slope first, and then they plug it into point slope form, and then solve. You get your y-intercept and your slope right there, and then they go ahead and graph it. Like I said, you don't have to go through and do any of that work because your calculator does it all for you later on. So here's your scatter plot, and this is the line going through this point here and this point here. Those 2 points. Connecting them through, and you can see that kind of does a good job of approximating kind of what's going on with those points, just drawing that line through it. But if we choose two different points, like if I chose this point and this point, I would get a completely different line approximating what's going on. So what we're going to want is everybody to have the same exact line, so we'll talk about how to find that line later. What they're going to do now is they're going to take this line, and this is going to be common that we're going to do in this chapter, to predict what happens if x equals 3. So if x equals 3, they plug it into this formula, and they get y equals 4.75. Right? So this is going to be our goal, is to get a good line here to approximate what's going on, and then we're going to use that line to approximate what we think is going to happen if we ran this experiment again and x is 3. So like if we find the least squares regression line for housing example, and we know how big our house is, and we want to figure out kind of what we would expect the selling price to be, we could use that line that goes through it to kind of give us approximation of what we think it's going to be. So come down here, they're going to define this thing right here. It's called the residual. So here's our line that they found. It's just one of the many lines, but this is the line that they found. And then this point right here is going to be 3, 4.75. Right? So this line is 3, 4.75. This is our predicted value. So if we want to predict y using our least squares regression line, we predict that it would probably be 4.75. When we actually had x equals 3 earlier, so up here in our graph, if x is 3, y was actually observed to be 5.2. This is something that was actually observed. So this dot represents our observed value, the one that we actually saw. And then this line, this dot here on the line, that represents our predicted value. If we did it again and x equals 3, what would we expect our y to be? And so that's going to be what we call the residual. It's basically the vertical distance between the dot and the line. So that's going to be called our residual. And for this case, it's going to be 0.45. All right, so it's a residual. I don't remember if we talked about residuals, but we might. Anyway, so that's the residual, the vertical distance between the two. So our goal is to make sure these residuals are as small as possible because we want those dots to be really, really close to the line. So if our goal is to make those residuals as small as possible, that's going to be a line called the least squares regression line. And that's what we're going to be doing in this section. So it's the line that minimizes, and it says the sum of the squared residuals. So if you take these residuals, square them up, and add them together, the smallest they could possibly ever be is with the least squares regression line. Any other line you pick, any of those, if you pick two points out of your data set and draw a line between them, and you take all the residuals, square them, and add them up, it's always going to be a larger number than if you have your least squares regression line here. So this line is going to give us the best approximation for what those dots are going to be doing. But to find the one that actually works the best is going to be a little more complicated than the stuff up there. Luckily, we don't have to do that because the calculator is going to do it for us. So, yay. Okay. And then the line that we have is actually going to be called y hat. It's got this little hat on top of it. And it's given by this equation where you can figure out the slope and the y-intercept. I think there might be one on the homework. This is the one where I think they actually give you the values, and you can use these formulas if you want to, or you could just plug it in the same way we do all of the other ones. So these are the formulas that you can use. It requires you to know R, your standard deviations, and your averages, but it's much easier just to do it on your TI-84 down here. And it's going to be the same program that we used the last one. We're going to do stat, calc, and then we're going to go down to number 4 for our linear regression. So if you go down to number 4, you're going to have the numbers here, but we'll go ahead and do this one next time. We'll start on that one because I want to pass out the tests real quick. Does anybody have questions before we're done? This is all lumped together in one homework and one quiz for Chapter 4. So the homework is from 4.1 through 4.3. So you can do some of the questions if you want to. Some of them we haven't talked about yet. So we'll finish it up on Monday, and then you'll be able to finish the homework and the quiz for this section. Yes?
When is it due?
Is it due? This homework and quiz is going to be due next Wednesday at midnight. Okay, so with the tests, I forgot to give you guys the formula.